As I mentioned, there you have a plasma iron pool, but iron is also stored in some organs in certain places. So iron is stored in the liver, the spleen, and also in bone marrow to make those erythrocytes. Now, the most important substance, the most important chemical that regulates iron absorption is called hepcidin. And so what happens is that the liver makes hepcidin, and what that does is it blocks ferroportin. Now, if you remember back to HS 10.1, ferroportin is the transporter that effluxes the iron from within the enterocyte across the basolateral membrane into the blood. So when the liver makes hepcidin, and hepcidin blocks the ferroportin and causes it to be internalized and degraded, you can't efflux the iron into your body. So you have less iron absorption. So hepcidin negatively regulates iron absorption. Now let's have a little think, well, what can cause the liver to make hepcidin? Why would you want to absorb less iron? Well, one of the reasons is you have high iron levels in your body, because remember, if you have too much iron in your body, there's no active excretory mechanism. Instead, it will cause the liver to make hepcidin and absorb less iron. Inflammation as a result of bacterial infection can also cause the liver to make hepcidin, which I'm going to explain in a bit. Low iron levels will stop the liver from making hepcidin, because if you have low iron levels, you want more iron. So if you stop the liver making hepcidin, it will prevent the ferroportin from being internalized and degraded. You will be able to efflux the iron, and so it will cause more iron absorption. Also hypoxia, because hypoxia means you have less oxygen. So if you have less oxygen, then you want the liver to stop making hepcidin so that you can absorb iron, make more hemoglobin, and so have a greater oxygen carrying capacity. There's two diseases associated with levels of hepcidin. If hepcidin is overexpressed, then you'll have a less iron absorption because you'll have too much degradation of ferroportin, so not enough iron absorption, which will cause anemia. And if you have underexpression of hepcidin, then you'll have hereditary hemochromatosis, because you'll have too much ferroportin channels, you'll be transporters even, you'll be effluxing too much iron into your body, causing too much iron in your body. So I guess the first major concept to understand is that high iron will cause more hepcidin to be created, and low iron will cause less hepcidin to be created. So let's see how that happens. Well, if you have high iron, then it's sensed by the liver cells, the hepatocytes, to make more hepcidin. If you have more hepcidin, then ferroportin channel will be degraded, internalized and degraded, so you'll have less iron efflux into the body, so less iron absorption. And if you have low iron levels in your body, then they'll be sensed by the liver cells, causing less hepcidin production, and therefore this will allow more iron absorption. Now, I mentioned that inflammation can also cause the liver to make more hepcidin, so let's see the explanation for that. Well, if you remember back to the functions of iron, one of the functions of iron is cell cycle regulation. So you need iron to regulate the cell cycle to allow proliferation of cells, right? So if you have a bacterial infection, you want to stop those bacteria from proliferating. You want to take the iron, you want to keep the iron away from these bacteria, right? So this is how you do that. Well, if you have a bacterial infection which will cause inflammation, then hepcidin will be produced by the liver cells. And this will stop iron efflux because of the internalization and degradation of ferroportin. And the iron will be locked up in macrophages. And well, this is good because the bacteria won't be able to get the iron to regulate their cell cycle and proliferate. However, if the iron is locked up in macrophages, then you'll have less iron cycling in your body, in the plasma iron pool, to make the red blood cells in the bone marrow. So, the inflammation as a result of bacterial infection will also cause anemia of chronic disease. Now, anemia of chronic disease, this is when you have iron in your body, but there's less of it cycling because it's been locked up in the macrophages because of this bacterial infection, causing anemia of chronic disease. So if we say that, well, inflammation is causing anemia of chronic disease and locking up the iron, the inflammation could also be caused by obesity. So we can summarize that here essentially. Inflammation causes more hepcidin production in the liver cells to keep iron away from bacteria, which is good. But this causes anemia of chronic disease because the iron is locked up in macrophages. But it's not just hepcidin that regulates iron levels in the body. Iron regulation also happens at the cell level, so cells also regulate iron levels in storage. If you have too much iron in the cell, what that does is it stimulates iron regulatory proteins, IRPs. Now IRPs do two things essentially. Well, first of all, if you think about it, if you have a lot of iron in your body, in your cells, and iron mediates free radicals which are toxic, then you're going to need more ferritin. And remember, ferritin is the substance that allows the inert storage of iron. So if you have too much iron in your cells, you're going to need more ferritin for inert storage. Secondly, if you have too much iron in your cell, you want the cells to absorb less iron. So you're going to express less transferrin receptors. Now remember, when iron enters the body from the enterocytes, it's bound to transferrin in the blood. And the cells present transferrin receptors to absorb the iron, liberate it by acidification, and then use the iron. So if the cell's expressing less transferrin receptors, there'll be less iron transferrin endocytosis. So the IRPs, iron regulatory proteins, they cause more safe storage of iron and less iron absorption into cells. Now I mentioned that obesity also causes anemia of chronic disease, so let's see how that happens. Well, if you're obese, then that causes chronic inflammation. And inflammation, remember, is one of the triggers for hepcidin, because inflammation also happens by bacterial infection. So you want more hepcidin to prevent iron being used by bacteria for proliferation. So if you have obesity, then you have chronic inflammation. The inflammation triggers more hepcidin production. And more hepcidin production, that will cause anemia of chronic disease, because you're locking up the iron in macrophages. And we can see here that bariatric surgery can prevent anemia of chronic disease. Why is that? Well, bariatric surgery on the stomach, will reduce obesity, because bariatric surgery will cause you to feel more full earlier when you're eating. So it will stop obesity, or reduce obesity, and therefore treat the anemia of chronic disease. So if anemia of chronic disease is caused by bacterial infection and obesity, well, what's iron deficiency anemia caused by? Because remember, there's two kinds of anemia here. So iron deficiency anemia is, as the name suggests, it's low iron intake in your diet. And what that will result is a low level of ferritin iron. This will be within your cells. So remember, because ferritin binds iron for inert storage, so you'll have low ferritin iron complex. But also you'll have low transferrin saturation. And transferrin saturation, remember, is the iron in the blood. It's bound to transferrin. So you'll have a low transferrin saturation in the blood and low ferritin iron levels in the cells. And because of this low iron levels in your body, by a negative feedback loop, this will cause the liver cells to produce less hepcidin. Because remember, hepcidin negatively regulates iron absorption. So if you've got less iron in your body wants to make less hepcidin to promote iron absorption. However, if we compare that to anemia of chronic disease, the anemia of chronic disease will cause, because of the inflammation, it will cause increased hepcidin levels, which is anemia, and that will cause anemia of chronic disease because it's packed up in macrophages. And so there'll be less iron circulating in the blood, so a low transferrin saturation. But the major difference is that you'll have high ferritin iron, so there'll be a lot of iron packed up in the macrophages, so high ferritin iron levels. And we can summarize that in this table here. Well, first let's look over here. So iron deficiency anemia has low iron, but anemia of chronic disease has iron, but it's trapped due to the high hepcidin, due to the inflammation. So if we see here, the transferrin saturation, which is in the blood, that will be low for both of them, less than 16%. The ferritin saturation will be low in iron deficiency anemia because you have less iron, but it will be high in anemia of chronic disease because you have iron, but it's just packed up in the macrophages and bound to ferritin. Hepcidin will be low in iron deficiency anemia because your body has less iron, so it wants to lower the hepcidin. Whereas in anemia of chronic disease, you have high hepcidin due to the inflammation causing the anemia of chronic disease. So you can use these three to differentiate between them. So transferrin, ferritin, and hepcidin levels can be used to differentiate between iron deficiency anemia and anemia of chronic disease.